Right, GCSE resit. This one was done in two parts. You need a calculator for this. Don't mess around with your phone. You need a proper calculator because we are going also to do trigonometry. I think it's trigonometry, isn't it? Yeah, trigonometry. Okay, right. Now, first of all, do Pythagoras. Everything is to do with right angled triangles. Now, first of all, here is, no, that's not a right angled triangle, is it? That's just a slopey line. Now, a right angled triangle is there, there, there. Now, Pythagoras is used to find sides. Yeah, trigonometry is used to find sides and or angles. There's a difference. Yeah, right. Now these appear in both higher and lower, so don't higher and foundation. Don't worry. So it only works with right angled triangles. Right. So I'm going to do A, I'm going to do B, and I'm going to do C. And for Pythagoras, we have this formula: a squared plus b squared equals c squared. This is the hypotenuse. Yeah. So if you've got a triangle and you've got some numbers in it and you want to find the hypotenuse, all you do is call that 10, call that I don't know, 12. So we want to find c. So we've got 10 squared plus 12 squared equals c squared, which is 100 plus 144 equals c squared, which is 144 equals c squared. Now you want to find the square root of this. Oh no, that's 244. Yeah, you want to find the square root of 244, and that will be the longest side. So let's get the calculator. Square root of 244 equals something a bit weird, is 15.62 centimeters or whatever it might be, centimeters, and that's to 2 decimal places because I'm just shortening my display on the calculator. So that's how you find the longest side. You square both the shorter sides and add them together. What about when you want to find a shorter side? Okay, do that. We'll do that. Got to be a right angled triangle. So 20, 15, and let's call this x now. Yeah. So when we wanted to find the longer side, we squared the shorter ones and added them together. Now we're going to find a shorter side, and it doesn't matter whether it's this one here or that one there. We take the longer side and we subtract the other one. Yeah, because short plus short equals long. Long take away short will tell you what the other short is. Yeah, so equals x squared. So that's 400 minus 15 squared. Should know that off by heart. 225 equals x squared, and 400 minus that is 175 equals x squared. The square root of 175 will equal x, which is the square root of that is 13.2, I'll call it 23, to 2 decimal places. It could be significant figures, it could be 1 decimal place, it could be anything. So when you're finding a short side, it's long take away a short, gives you the other one. And I'll do one right next to it, and this is going to be finding 10, 8, and x. Now we're going to be finding this one, So it's simply 10 squared minus 8 squared equals x squared. So that's 100 minus 64 equals x squared. 100 minus 64 is 36 equals x squared, and the square root of 36 equals x, which is 6 equals x. So it doesn't matter which short one you're finding, it's exactly the same thing. Now, the other part of this was the trigonometry. Now, again, it's to do with right-angled triangles. Now, remember, trigonometry is used to find angles and or sides, right? So you can find sides and you can find angles. So let's have an angle in here of 30 degrees. And we're going to use our calculator for this, yeah? So first of all, let's say we're going to find the long side. So say that's 10. That's it, yeah? We'll find the long side. So all we've got is one side and one angle. So first of all, we need to label up the sides. Right, the longest side of a triangle is always called the hypotenuse. Always. Opposite the right angle is the hypotenuse. Now, imagine you're standing in the triangle where the 30 degrees is and you look across the triangle. This side becomes the opposite. And this side, the third side, is the adjacent. Now, if we have, we'll go back to this one. If we have a triangle like this, and we've got that as 30, this is still the hypotenuse, but now this one becomes the opposite and this one becomes the adjacent. Yeah. So depending on the point of view of which angle you're on about, the opposite and the adjacent can swap over, but the hypotenuse remains always the same. So we're going to look at this one. So now we've got the things labelled up, we need to write down this lovely formula. So, ca, toa. Always write that. Always write that. Now what this is to do, this is telling us it's divided up into 3 sections. Sokotoa. This tells us, gives us 3 formulas we can use depending on what we know. And we decide, once we've labelled up the triangle, which one we're going to use. The so. This means the sine of the angle, and I'll give it that little theta thing. The sine of the angle equals the opposite divided by the hypotenuse. This one, the cosine of the angle, equals the adjacent divided by the hypotenuse. And this one is the tan of the angle, which equals the opposite. That little thing there, by the way, with it, yeah, it's called theta. Theta. It's just a Greek letter to denote the angle, yeah? Opposite by the adjacent. And you see we've got the OH, opposite hypotenuse, AH, adjacent hypotenuse, OA, opposite adjacent. Now, what do we need? We need now to pick out which one of these 3 we're going to use. Now we want something with the opposite in it because that's what we know, and we want something with the hypotenuse in it because that's what we need. So opposite and hypotenuse is going to be this one, yeah? So we're going to do sine. The angle we've got is 30 equals the opposite, which is 10, divided by the hypotenuse. Okay? Ooh. So we now have to rearrange this so that we've got the hypotenuse on one side and all the rest on the other. So we swap these 2 around. So we say that the hypotenuse is now equal to 10 divided by sine 30. Yeah. And on the calculator, we just do 10 divided by, press the sign button, enter 30 into that, and that comes out at 20. So the hypotenuse is 20, whatever it is, centimeters or meters or something. So that's how to find a side rather. How to find a side. I'm going to do another one. We're going to find another side. And we go on. So that was finding the hypotenuse. So let's do another one. And there's the thing. And there we go. We'll still do the same angle, but this time we want to find this one. Yeah. And we know that's 4, and we know that's 7. Yeah. So first up, label. From there, opposite, hypotenuse. Oh no, we don't need all these numbers, do we? I was Pythagorasing then, wasn't I? Opposite, hypotenuse, adjacent. So we're gonna write so, ka, toa. Now we need something with the adjacent and the opposite in it. What we know and what we need. Adjacent and opposite. That's this. So we're going to go tan 30 equals the opposite 4 divided by the adjacent. The adjacent is what we need to find. So again, swap these round. So the adjacent is equal to 4 divided by tan 30. Yep. So let's do that. 4 divided by tan 30 is equal to 6.93. Let's find the opposite. Let's find the opposite. So we're finding all the sides, yeah? So we do our old favourite 30. So we want to find this one. So this is down the x. Yeah, so call that 30 as well. No, because it might get muddled up with that 30, so we won't do that. We'll call that 32. Yeah. And so we need to label them up. We've got the hypotenuse. There's the hypotenuse. And we've got the opposite there. And the adjacent we don't know and we don't need, so we don't bother with that. So so, ka, toa, which is we need something with the opposite and the hypotenuse in. That's this one. So sine 30 equals the opposite, which we need to know, divided by the hypotenuse, which is 32. Now we rearrange this a little bit to go 32 times sine 30 equals opposite. Now, write the 32 before the sine 30. Otherwise, if you write sine 30 times 32, your calculator will get confused because it will be trying to do 960 something. So write the number before so that when you bang things into the calculator, they always come in the right way. So let's work that out. So we've got 32 times sine 30 is 16. Is 16. That's good because it's smaller than the hypotenuse, which it should be, 16. So that's finding all the 3 different sorts of sides and things. You can have any combination where you could find the opposite but you're given the adjacent, or find the adjacent where you're given the opposite, or vice versa. There's lots of different combinations there. So let's do finding an angle. So here we go. Here's a lovely one, yeah? So now, we don't know what that is now. So let's have 15 and 25. So we've been given 2 sides and we've got to find an angle. So still go through all this, yeah? Label up the sides and write so, ka, toa. Now, what do we need here? What do we need here? So we've got the hypotenuse and we've got the opposite. So that's what we need, hypotenuse and opposite. So it's that one again there, isn't it? So the sine of angle x equals 15, the opposite, divided by the hypotenuse is 25. So if we go 15 divided by 25, that is 0.6. So sine x equals 0.6. Now, we've got to now go from a number, where we go? From a number back to an angle. Before we were doing sine 30, the angle equals something or other. This time we're going back and we're going to use this thing on your calculator, sine minus 1. It's basically just shift sine. So this will take us back to the number. So you go shift sine and you get an open bracket there, and then put in 0.6, and this tells us that it's 36.87 degrees. Let's do one where we've got the opposite and the adjacent. Opposite and the adjacent. Opposite and the adjacent. So you do have to rearrange formulas sometimes, but the SOHCAHTOA gives you the, let's find that one, and we'll have 12 and 15 there, and so we label them up. We've got to find the angle x, so this is the opposite, this is the adjacent, this is the hypotenuse, and we write down SOHCAHTOA. Yeah. So we want something with the adjacent and the opposite in, which is that one. So tan, the angle x, equals the opposite divided by the adjacent. So 12 divided by 15 is 0.8. So we've got tan x equals 0.8. Now we do the shift tan this time. So we've got tan minus 1 and 0.8 in the calculator. So shift tan 0.8 equals 38.67. 38.67 degrees. Okay, one more where we'll put the angle at the top and see what happens. Yeah. So let's find out that angle. So here's our, oh no, I won't label it up. So let's call that 38, and we need to find this one up here. No, we need, oh, we need another number, don't we? Yeah, 52. So we need to find the angle. That's what we're after. So let's label them all up. So now this one becomes the opposite, this one becomes the hypotenuse, and this one becomes the adjacent because the angle's in the other corner. So again, SOHCAHTOA. So we need the opposite and the hypotenuse. Opposite and the hypotenuse. Yeah, that one. So sine x equals the opposite divided by the hypotenuse. So 38 divided by 52 is a bit weird, this one. 0.7, I'll call it 0.73. So sine x equals 0.73. So you go shift, again, you go shift sine and 0.73 on your calculator. So shift sine 0.73 equals an amazing 46.87 0.89 degrees to 2 decimal places. And that seems reasonable, 40 odd degrees, yeah? Obviously, you're going to get answers of more than 90 or something correct. You'll know you've done something wrong. So there you go. So that was a bit of trigonometry, a bit of Pythagoras as well.